Hi there. Now, have you ever tried to jump from the ground? What did you experience? Gravity didn't let you go, right? It feels like you can tell gravity to let go of some things. Now, remember, in our previous lesson on force field, we talked about the three of the most important types of force fields, right? We said these were the gravitational force, the magnetic force, and the electric force. We explained that these forces do not make physical contact with the objects they act on. And so, to enable us create a picture of them, we usually use field lines. So in this lesson, we'll be studying about the gravitational field lines, while in the next lessons, we will be studying about the magnetic and the electric field lines. So first of all, gravity is a force, okay? And this force pulls things together as long as those things have masses. So the more the masses, the more the gravitational pulling them together. This is why it is very evident that we are all attracted to the Earth, because the Earth has a very large mass. In fact, the most important or the most massive object around us is the Earth. Now, just to give us a picture of how big the Earth is, the mass of the Earth is about 6 times 10 raised to the power of 24 kilograms. Now, let me illustrate what this will look like. The value is more than the mass if you combine 1 billion people together and multiply this by 1 trillion. Do you see why the gravitational attraction between us and the Earth is obvious? Yes, because the mass of the Earth is very large. So the Earth's gravitational force wants to pull everything around the surface of the Earth towards the center. And so the Earth's gravitational field lines are simply directed towards the center of the Earth, as you can see on this image. You should know the following about the Earth's gravitational field and its field lines. Now first, the Earth's gravitational field exists in all regions of space surrounding the Earth. Now this is why you see the field lines are drawn around the Earth's surface. The gravitational field is a vector, and so it has both a magnitude and a direction. Also, the direction of the field is indicated by the arrows on the lines. As you can see from the image on your screen, the Earth's gravitational field is directed towards the center of the Earth. Finally, the magnitude of the field is indicated by the closeness of the field lines. So what do I mean? I mean, the field is stronger where the lines are closer to each other, and the field is weaker where the lines are further apart. Now you should observe from the image on the screen that the field lines are closer to each other on the Earth's surface than they are as they move further apart from the Earth's surface. This is correct because we actually experience more gravitational pull when we are close to the Earth's surface than we do when we are further apart. Can you see exactly why astronauts experience weightlessness when they are in space? This is because they have moved to a region of space far from the Earth where the Earth's gravitational pull is weak. Now, remember we said during our lesson on motion that whenever a force acts on an object, it causes the object to accelerate. In other words, there is therefore an acceleration accompanying every force. So the acceleration accompanying the gravitational force is known as the acceleration due to gravity, or just the gravitational acceleration. Now this is what we'll be learning about in our next lesson, but for now, we'll end this lesson here. But before we go, let's summarize what we learned today. First of all, we learned that we use field lines to create a picture of how field forces act on objects. Secondly, we said that gravitational fields are vectors, okay? And so they have both magnitude and direction. We said thirdly that the Earth's gravitational force pulls everything around the Earth towards its center, and so the gravitational field lines are directed inwards towards the Earth's surface. And finally, we learned that the Earth's gravitational field lines are close to each other at the Earth's surface than they are as you move further apart from the Earth's surface. This indicates that the field is stronger when we are close to the Earth's surface than it is further away from the Earth's surface. So I'll see you guys in the next lesson. Bye for now.